If A is the area of a circle with radius r, and the circle expands as time passes, find dA dt in terms of dr dt. So remember, this just represents the derivative of the area function, or the rate of change of the area. So the first thing I'm going to think about is the relationship between area and radius. Remember that the area formula for a circle is a equals pi r squared. And in order to get dA dt, I'm going to differentiate both sides implicitly. Because as time goes by, area changes, and as time goes by, radius changes. But I don't really know what those functions look like in terms of time, so it's not like I could solve for t here. So I'm just going to differentiate both sides of the equation. If I take the derivative of a on the left-hand side, that just becomes dA dt. That's the derivative of a with respect to t. On the right-hand side, I have a constant times my radius squared. So for the constant, I'm just going to bring that down, because I'm just multiplying that to a function of time. But for r squared, I'm going to apply the chain rule, right? So I'm going to bring down the 2, subtract 1 from the exponent, so that's just r to the first, or just r, and I need to multiply by the derivative of the inside function. So in this case, the inside function is just r. So I'm multiplying by whatever the derivative of r is. So this is the relationship between the rate of change of the area as time goes by and the rate of change of the radius. So let's apply this in context. For B, suppose oil spills from a ruptured tanker and spreads in a circular pattern like that. If the radius of the oil spill increases at a constant rate of 1 meter per second, how fast is the area of the spill increasing when the radius is 30 meters? So we're looking at this circle at the 30-meter mark, when the radius is 30 meters and it's still increasing after that. The important piece of information here is that they tell me that the radius increases at a constant rate of 1 meter per second. So that's telling me that the rate of change of the radius always is going to be 1 meter per second. And in this instant, I'm looking to see what the rate of change of the area is, or dA dt, that's what I'm looking for, when r equals 30. So if I'm looking at the relationship between my rates that I have in part A, I'm looking for dA dt. Pi is just a constant, 2 is just a constant. My radius in this case is just 30, and my dr dt represents my rate of change of the radius, which is just 1. So really, the rate of change of my area with respect to time, if I just simplify this, that's going to be 60 pi. And you could always type that into your calculator if you want the decimal approximation. The only thing you need to think about is the unit. So think about if it's a rate of change of the area is going to be measured in distance squared. And the time here is in, let me just go back and look, seconds. So it's meters squared because it's an area per second.